Example 124, calculate the horizontal deflection at C considering all effects. The bar is 75 mm in diameter, modulus of rigidity 83 gigapascals, and modulus of elasticity 200 gigapascals. What would have been the value of the horizontal deflection if shear effects were neglected? Neglect weight of bars. So let's section. There are only two segments. So that's the first section. This is the second section. So let's analyze the effect of the load to the first section. Of course, it will bend. So moment and shear at this section here. In the second section, uh, by action reaction, it will bend in this manner. There is also torsion. The value of the torque is 600 times 1.2. So that's the twisting effect. So there is torsion in this section here. That's the direction of the torque. And shear also, because the section is circular and we have force parallel to the applied load. So again, first section, moment and shear. In the second section, bending, torsion, and shear. So those are the effects in the second section. So delta horizontal is integral 0 to 1.2, bending first. So let's denote um, the 600 Newton horizontal force as P, because it is already there and it is 600 newtons. In this case, let's assume it is 0.6 kilonewton, so that the factor later for moment would be, the unit would be kilonewton meter cube in the numerator and kilonewton meter square in the denominator. So that's why we have to multiply for bending and torsion 1000 to the fourth if the force is in kilonewtons and the distance in meters. So the moment is px, the derivative with respect to p is x, dx over ei. Then the shear effect, the shear is p plus 10 over 9, because this is circular, integral 0 to 1.2 of p, derivative 1, dx over ga. Then those are the effects in the first section. In the second section, plus moment again, 0 to 1.8 of px. The moment is p times x. The partial derivative of px with respect to p is x, dx over ei. Then torsion, the value is p times 1.2 plus torsion, torque p times 1.2, the derivative is 1.2 dx over gj. Then finally shear plus p, 10 over 9 integral 0 to 1.2 of p, partial derivative is 1 dx over ga. So substituting prior to integration, remember that p is 0.6 kilonewton. Then the value of the first integral is 0.3456 over ei. The second one is p is 0.6. Take note, so 0.8 over ga. This one is 1.1664 over ei. This one with p 0.6, 1.552 over gj. Then finally p 0.6, 1.2 over ga. Then combining like terms, delta H or horizontal displacement in the direction of the load is 1.512 over EI, for torsion 1.552 over GJ, and for shear overall 0.8 plus 1.2 is 2 over GA. So only the last term will be multiplied by 1000 square, and all other values should be in mm to the fourth, mm square for area, and megapascals for E and G, so that the result will be in mm. So delta H is 1.512 times 1000 square, 1000 fourth rather, over E 200,000. I is pi over 64 diameter to the fourth, 75 to the fourth, plus 1.552 times 1000 to the fourth, over 83,000, then pi over 32, the polar moment of inertia diameter to the fourth, then plus 2 times 1,000 square over 83,000 times area pi over 4 diameter square, 75 square. So the value of the contribution of bending is equal to 4.8675. Torsion, the contribution of torsion in mm square is 6.0320, and for shear 0.005454. So again, the contribution of shear is very, very small. That in structural analysis for beam deflections, with our experience, we may ignore it to simplify the calculations. So delta H is equal to 10.905 mm. So for the question, what would have been the value of the horizontal deflection if shear effects were neglected? So we do not include this value in the calculation, and delta H would have been 10.900 mm, which is, what is 0.005 mm? 1 mm is very small, so 0.005 mm, they are practically the same. So that's it for this problem.